Up next, we have Will Hill, and I've written out 1,000 times, but I'm probably going to mispronounce this. Is it CuDes, LLC, and then Greg Shields from NetFoundry. And Will, you're up. Hi,
Thank
gentlemen.
you.
How are we doing today?
Fantastic. Can you hear me okay?
All
right.
All good.
Well, thanks everybody. Let me get to the next slide. So, hello everybody. My name's Will Hill. I am a technology broker at CuDes. Joby, you said that close enough. Thank you very much. Greg, would you be so kind to introduce yourself?
Happy to. Thanks very much, everybody, for having us today. My name is Greg Shields, and I'm a director of our strategic partnerships here in North America for NetFoundry. We're a network as a service company headquartered in Charlotte, North Carolina.
Awesome. Thanks, Greg. So the reason I am talking about this technology is because at CuDes, we handpick the technologies that we represent. And we are lucky that NetFoundry has chosen CuDes to be a sales representative for them, because this technology is a game changer and it was not commercially available until recently. The reason I call it a game changer is because it allows for a 100% software implementation of a security policy implementation. So there's no hardware that's required. And automotive companies are always looking for opportunities to stop paying for hardware or services, while also being able to extend the life of legacy systems. So let's review the agenda for today. So we're going to talk about what is zero trust network access. Then we'll talk about what is network micro-segmentation. And then what has this got to do with connected and autonomous vehicles? And hopefully we'll have some time to take some questions from the audience. So what is zero trust network access? The way I define it is, no one can see that an endpoint or a piece of hardware exists. A piece of software, a device or user can't even exist until it's authenticated. And then the firewall that you may have in place, you actually would turn off all the incoming ports so it wouldn't receive any messages. So that's how I interpret zero trust network access. Greg, how do you define it?
Well, it's interesting. The phrase was first uttered by an analyst for Forrester back in 2010. So it's certainly not a new concept. And I think we can agree that the name was definitely developed by somebody who's an analyst and not somebody in marketing. Zero trust, I don't have any trust, how can that be a good thing? But what this guy said was, he said that networks have become complicated and dynamic. I started in this industry in the late 90s, and I remember back then, I'd go to work with a StarTAC phone in my pocket, fire up a desktop computer that sat under my cube, run that computer using applications that were either on that machine itself or were accessing a server that was inside the same building. And at the end of the day, I'd shut that computer off and go home. And we had a headquarters and a couple branch offices, and that was it. But if we think about networks in 2021, there might still be a headquarters and branch offices, but a lot of those are going to be empty because people are working remotely because of COVID. There's going to be third parties. There's going to be private data centers, public data centers, multiple public clouds, IoT devices, and those things are fluid and dynamic and changing all the time. And what this analyst sort of predicted is you saw this direction we were moving in from the way network architectures looked, was that when we continued to just automatically trust anything because it existed on a network, we were opening up that network to all sorts of security vulnerabilities. Instead, what we need to do is we need to trust nothing until that thing can authenticate to the network in such a way that we're comfortable it is who it says it is. And then what we should do is only give them access specifically to the resources that they need to do their job and nothing else. So that was 2010. And like I said, here we are in 2021. And Zero Trust Network Access, or ZTNA, we'll put the common acronym for it up there, has really come a long way. The National Institute of Standards and Testing has actually put out an official framework for what ZeroTrust is as far as NIST is concerned. When I started at NetFoundry in 2018, most folks I spoke with had never heard of it. Now virtually everybody's heard of it. But it really incorporates a lot of very different approaches to network security that lock down how different entities on any given network access resources and applications. And that becomes pretty important when we start talking about things like connected or autonomous vehicles.
Awesome, awesome. Thank you very much for that definition. So let's talk about what is network microsegmentation. So the way I defined it is being able to connect to one app or one device or a router or to any other single or multiple apps or devices. So one little piece can talk to one little piece, or one piece can be broadcasting. Greg, how do you define network microsegmentation?
Well, if we think again about those complex networks that I referenced in the earlier slide, Will, and the fact that there's so many different applications running and different applications are used by different people with different personas and different responsibilities, just because we have one big network, we really shouldn't be enabling anybody on that network to move anywhere else on that network. Obviously, we can protect resources with usernames and passwords, but we all know that those are not secure. How many times have you seen a Post-it note hanging from somebody's monitor that has a username and a password on it? So what we really need to do is we need to lock down who can reach what based on the job that they're trying to do. So we might have one big network that incorporates all of the endpoints, locations, clouds, that are part of our enterprise, but we're going to take that big network and we're going to chop it up into much smaller networks using the concept of microsegmentation, where we very tightly control within the framework of our large network who can access what based on roles and responsibilities inside that bigger network. And NetFoundry has done some really interesting work on microsegmentation, because what we have done, and Will referenced it earlier, there is no NetFoundry box. Everything that we do is software. We've got the ability to push that trust deeper inside an environment than just at the edge of an environment with a piece of CPE that you might traditionally, or customer premise equipment, you might traditionally find in standard network deployments. We've got the ability for, not only can we mirror that model where you could have a NetFoundry edge router sitting at the gateway between your WAN and your LAN, and it can protect your LAN and the private resources behind it. And we refer to that as ZeroTrust network access, but we can even go 2 steps farther than that. We can remove the need to have any sort of either virtual or physical router at that gateway between WAN and LAN, and we can install our software on a host that's serving up an application and extend that trust all the way down to the server host. But here's what gets really cool is we've taken the software at NetFoundry that we've implemented for our endpoints, and we've open sourced that software. So some folks were mentioning earlier in autonomous vehicles, there's applications running. You can actually, if you own the code for those applications, you can use our SDKs and you can insert our code into that application and effectively isolate that application, not only from the local area network and the WAN, you can isolate it from the server upon which it's running. And that really is true ZeroTrust nirvana, if you will. That's extending the trust all the way down as far as it can possibly go. And again, NetFoundry is the only company on the planet that's provided that level of security to its customers through SDKs installed directly in the customer's applications.
That's impressive that the SDK can be put right into the code. So you can have multiple apps and each having their own microsegmentation?
Absolutely. Well, so imagine a world where you've got a server and it's running 4 or 5 different applications, and different folks need to be accessing those applications with different jobs. You can microsegment your network all the way down through the LAN and through that host itself, effectively making those apps each individual endpoints on a secure ZeroTrust network through the NetFoundry SDKs.
That's interesting. Now, what about, what does this mean for like systems that are legacy or that may have been designed before they wanted to connect it to the cloud?
So there's lots of different ways that you can address situations like that. Again, we've got all of our SDKs, they run in stuff like Java, they run in C. So, I mean, if someone's running Fortran on their autonomous vehicle, good luck. But if you're running any kind of a modern programming framework, you can insert our code into it. But let's say for argument's sake, you can't. Let's say it's running something proprietary. It's not Linux-based, it's something else. We have customers that have deployed IoT devices, and let's be honest, a autonomous vehicle or connected vehicle could be considered an IoT device. And they can use compute as small as something like a Raspberry Pi, where they can install our endpoint software running on that, and that could effectively protect that as well, and microsegment what can be reached sort of behind it from almost like a gateway kind of perspective. So we can control that trust that way as well. So again, because you're working with software, you've really got the flexibility of deploying it really where it makes the most sense based on if it's a greenfield, brownfield opportunity. And something else that another one of the speakers mentioned just before we got on is that it made sense for all of these applications to be moving to the cloud. We certainly believe that to be the case too. And as we are software, you can go find the NetFoundry software in every one of the major cloud vendors' marketplaces: AWS, Azure, GCP, Oracle, Alibaba, IBM, DigitalOcean. And you can actually spin up instances directly out of their marketplace with the NetFoundry software. So as you're building that device to cloud connectivity, edge to core, you can secure it all programmatically through the NetFoundry platform.
Neat. So let's talk about what has this got to do more, other automotive and connected vehicle use cases. So the way I, some of the challenges I'm seeing in the automotive industry is, the quantity of organizations who want to access data or even control a vehicle subsystem, that keeps increasing. So there's more ecosystem players is a challenge. The other one is the apps and the hardware and what it talks to as well is constantly changing. Every year there's more technologies, customers are bringing their own apps. So, the challenge I hear from automotive customers is, what can I put in place that does not have to change and which reduces the cost of change when there's new apps and new hardware? So, Greg, how can an organization in the connected vehicle space leverage zero trust network access?
Well, you made a great point kind of right at the end there, Will, about how can organizations remain flexible and not have to swap things out. And our answer to that would be open source software. And NetFoundry is open source that software. And we have folks in the community contributing to the code. We have folks that are leveraging it. And when that software is open source and it's written for multiple SDKs, you've then got the flexibility that comes with software instead of relying on some piece of proprietary hardware. But the other thing where it really makes sense to leverage a zero trust approach like NetFoundry is just what you see here. If you think about connected vehicles and autonomous vehicles, they really are, in many cases, extranets. You might have the infotainment systems might need data or information that would come from one specific source. There's probably a telematics system that is handling things like navigation. You also might be pulling diagnostic information from different parts in the car. Imagine if it's an electric connected vehicle, you might have data that's being pulled just about battery usage, that maybe that data needs to go back to the company that made the battery for them to analyze how their devices are performing in these specific cars. But you wouldn't want somebody that makes batteries to be existing in the same part of the network where navigation might be, because you don't want the battery guy doing something untoward, making the car turn left instead of right. So when you think about these connected vehicles as really being extranets, you need to start looking at how do I lock down the connectivity so that the people who are collecting data or sending data to this vehicle are only touching the systems that they need to touch. And again, you accomplish that through zero trust. But then I would say you need to take it one step farther. You're not going to be installing equipment in these cars. You want to leverage software. And the NetFoundry solution gives manufacturers of these type of vehicles the ability to leverage software and not get stuck or roped into some kind of a specific environment.
Thank you very much. And then, Greg, would you explain this next slide to
Yeah,
us?
so again, we're just kind of mapping out here the concept of micro-segmentation. At NetFoundry, we refer to those micro-segmented smaller networks as app-WANs, or application-specific wide area networks. And this just shows, again, the power of software, that it doesn't matter to me or any of us at NetFoundry what we're connecting to. Is it the vehicle itself? Is it the driver running iOS or Android, or possibly using SDKs from other type of programming frameworks? Is it somewhere in a secure data center? Do we have third parties connecting? Do we need to provide remote access to a mechanic to get into a vehicle to troubleshoot? Do we have the factory that's building the vehicles, collecting data off of them? Any of those type of endpoints can all be implemented with software, managed through a single pane of glass, and then micro-segmented from each other using the NetFoundry's application-specific wide area networking.
Fantastic. So that's impressive. Let's see if there's any questions for the audience.
So Will,
yes,
this question is from the audience. How is micro-segmentation different from VLAN-based or firewall-based segmentation?
So there's a couple different things that we take into account there. Micro-segmentation really applies to a wide area network kind of a concept. So you don't really typically think of it as a local area network application. You could certainly argue that if you are building multiple VLANs inside of a single environment, that could be argued that that's a kind of bit of a micro-segmentation. But again, when we talk about VLANs, we're really talking about segmenting out IP addresses. We're not taking it farther down by separating out inside something with ports and protocols. We're applying that sort of a framework to a WAN connectivity. Firewalls are interesting because they perform a lot of different roles these days. A firewall, if you're looking at something like a stateful inspection firewall, is inspecting packets as the data is either ingressing or egressing an environment. Sometimes you have to use a firewall if you want to be granular about your rules about what ports are open for inbound traffic. What we do at NetFoundry is you could actually deploy a NetFoundry solution and remove the need for any kind of a firewall at all. And what I say by that is, imagine it's an environment where there's a router. You could just default set on that router. Anything inbound is blocked. Anything outbound is allowed. One of the things about the NetFoundry endpoint software is the NetFoundry endpoint software initiates the connection into the controller inside of our fabric to handle things like authentication and understanding policies. So you can create, as Will kind of referenced in his first slide, you have the ability to create a completely dark network that is not visible from anywhere on the internet by leveraging that NetFoundry endpoint software and leveraging its ability to only make outbound connectivity. Firewalls, there tends to be a need for a public-facing internet address on that firewall. And if I've got a device that's got a public-facing internet on it, I've opened up the possibility for a security incident in case there's vulnerabilities with that firewall, mismanagement, what have you. We keep everything dark and invisible to the public internet. And I hope that answered the question, Joby.
All right. The other question I see here is, are there any standards or open source tools that I can use to work on network segmentation?
Well, I guess the standard that I might point back to is the National Institute of Standards and Testing, or NIST. Their definition of what is zero trust deployment or environment looks like is all codified inside that NIST document. And on NetFoundry's public-facing website, you can find a white paper that discusses how NetFoundry is completely compliant with those NIST standards. From an open source perspective, I would encourage you to wander over to our software open source website, which is called zd.dev. That's ziti.dev. And there's links in there to our GitHub presence, so you can see what our code looks like and how we implement it, and go check it out if that's something that's interesting to you.
Well, Greg, thank you very much. I think we're at time. Feel free to contact me if you would like any more information. And thank you all very, very much.